So in this video, I'm going to review all of the concepts that we have gone over in the unit thus far. So first of all, I want to talk about this graph. So these three are different types of transformations. And so we're going to talk about what do these transformations produce. They all three do produce congruent images. So we're going to go from blue to red. And so in the first one, you guys should all notice that it's a translation and that we moved 4 to the left and 1 up. The next one, this middle one, hopefully all of y'all can see that that's a reflection, and it's a reflection over the x-axis. Oh, and the first one, by the way, when I write the congruency statement here, it's P prime, Q prime, and R prime, and if you remember, that's what we did when we did the last unit as well. Second one was A prime, B prime, C prime, and again, that's kind of hard to see in even the drawing, but nonetheless, that's what it is, okay? So then the third one is a rotation, and I want to remind y'all that we rotate counterclockwise. So this is a rotation, 270 degrees. So this is R prime, E prime, C prime, and T prime. Okay, so on the next one, go ahead and look at it a second. Hopefully all of y'all can see that angle Q, R, and P are congruent to angle J, K, and L, and that we have congruent sides as well. We have one tick on PR and one tick on LK, and so on and so forth. So we can say for this one that all sides and angles are congruent, right? And as a result of that, if we have that statement first, then we can use Cpctc. So this is when we would use Cpctc to solve missing parts. So now, let's go ahead and write our congruent statement. So Q has one arc and J has one arc. Sorry, I meant to say, yeah, I said that totally wrong, y'all. So P has 3 arcs and L has 3 arcs, so we got to put the L first. Then Q has 1 arc and J has 1 arc. Then R has 2 arcs and K has 2 arcs. So that's how we write our congruent statement. On this next drawing, the first thing we need to do is mark the shared side. So we're going to do that first. Then hopefully you guys can see that this is side, side, side. That's why the triangles are congruent. And then we need to write our statement, triangle ACD is congruent with what triangle? And on this one, triangle ACD is congruent with CAB. Now I'm going to talk to y'all about how, another way that I can determine that, okay? So I could go over here after I know that these triangles are congruent, and I can start looking at angles. So I know that angle D, which is between 1 and 2, is congruent with B because it's between 1 and 2. And angle A up here in this left triangle is congruent because it's between 2 and 3 with C because it's between 2 and 3. Now that will help me to write my congruent statement. So notice that A has 2 arcs on it and C has 2 arcs on it. B has 1 arc, C has no arcs on it on the left triangle and A has no arcs on it. And then in the last one, D has 1 arc and B has 1 arc. So that's what you guys need to be looking at. Here again, we're going to mark the shared side. So hopefully you guys can see that this is side, angle, side. And once again, when I move around the triangle, it says ABC. So we're going across the 1 tick side to the 1 arc to the 2 tick side. So that's what we're going to do with the other one. So this should be DBC. All right, so the next one, the one on the bottom of the page. So here we have a shared side and we have another right angle over here. Those angles are a linear pair, so they're going to add up to be 180. So here again we have angle, side, angle. Angle at the top, side in the middle, angle on the bottom. This one is UVX is congruent with WVX. Our next one has another shared side. And here again, we've got angle, angle, side. So this is going to be angle, angle, side. And when I look at M and P on this one, M has 2 arcs, N has 1 arc, and P has no arcs. So we're going to move the same way around the other one. 2, 1, none. So this one is going to be ONP. On the next one, we have, again, another shared side. So these are right triangles. That's our first condition. Then we do have the hypotenuse of both of these because that's the one that's opposite the right angle. And then we have another leg. So this one's going to be HL. And again, we've got A, B, C. So A has nothing on it. B has a right angle. And then if I go across the side BC, it's got 2 ticks. So that's the way I'm going to move across the other one too. So it's going to be DCB. So this next one here is, notice that I've got a side, and an angle. So this would be side, side, angle. And remember, I told you guys no button, no butt backwards. That's butt backwards right there. So we don't have enough information here. The only time we can have side, side is when we have side, side, side. So this one's going to say not enough information. So we cannot prove congruence. So our next one is Quadrilateral Klmn. On this one, notice that we have a pair of parallel sides. We do have a shared side, and then we have a pair of parallel sides. So here again, we can say that these angles are congruent, and they're congruent because they're alternate interior angles, and we did one like this yesterday. The problem with this is right now I only have one side and one angle in each of those triangles, and again, I need a minimum of 3 pieces of information. So I, again, don't have enough information. So I cannot prove congruence. Now they could be congruent, but I can't prove it because I don't have enough information. This next one down here, we have another shared side. And this time again, we only have 2 pieces of information. We have side, side. So here again, we do not have enough information. So we cannot prove congruence. So here we have triangle ABC and triangle DEF. And notice that we have 2 angles, and obviously we could say that the third angle was congruent up here because of the third angle's theorem. However, we don't have any sides. So all we have right now is angle, angular, angle, angle, angle. So we do not have enough information. So here's the thing again, you cannot prove congruence unless you have at least one side. So we don't have enough information. So again, we cannot prove whether they are congruent or not. And I'm pretty sure all of y'all can see that they're not congruent because one is a dilation of the other. So the next one. So when we deal with these next concepts, we're actually going to work through these drawings again and we're going to talk through them. So on this next one, I noticed that I have some parallel lines here. So we know that BD is parallel to AC or CA. Doesn't matter how we put this one because we're just talking about parallel lines. And that DA is parallel to BC. So I noticed that, so I'm going to write about that. And then I also notice I have I have a shared side. So here I should be able to mark that this angle up here, DAB, is congruent to CBA. And the reason I can write that is because they're alternate interior angles. Same way here. These two angles, that pair of angles right there are congruent as well. So if I'm writing this statement, I would say BAD, angle BAD is congruent to angle ABC, and our other pair is angle DBA is congruent with angle CAB. Now, the reason those are congruent is because they're alternate interior angles. So we're going to say alternate interior angles theorem. That's why we could make those arcs on those angles. Okay, then we can say that triangle ABD is congruent with triangle BAC by side, angle, side. Sorry, angle, side, angle. I said that backwards. I wrote it backwards too. So it should be angle, side, angle. Look back at your drawing. It's angle, side, angle. All right, the next one down here, let me actually move it to the top. So this next one says P is the midpoint of BC. So first of all, I can mark these sides right here because we know that they're congruent because they are the same length. Also, we could mark that BP, we know that BP is congruent with CP because that's what the midpoint tells us, that these are congruent. So right now I don't have enough information to prove that it's congruent. However, well, actually I do. I have hypotenuse leg. So if this is all I did, I have hypotenuse leg. However, if I went ahead and marked these vertical angles, I have some more information. I could use angle, side, angle. I could use side, angle, side. I could use angle, angle, side, or I can use HL. So there's a bunch of them that we could use here for this one based on the information that's given to us. So we can say again, triangle ABP is congruent with triangle DCP by angle, side, angle, 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 side, side, angle, side, and HL, all of them. And the thing that we were talking about here was that definition of a midpoint. It'd be good if I could spell, huh? That's what we used in this problem. Okay, so on this next one I want to talk to y'all about, we already did this problem earlier, and notice here we're going to have XV is congruent to XV. We're moving the same direction across the sides. So this is the reflexive property. And then on this other one, we have, we're moving from one tick to two, or one arc to two. So that would be FH, and that's congruent to HF. Now this is the same segment, so technically we could still use the reflexive property. Let me write this so you guys can read it. But we also, it's not two segments, it's the same segment, so we could use a reflexive property. But it looks a lot like the symmetric property to me because we're flipping them, okay? So now this next one is, we could say that, sorry, that looks like a C instead of an arc. We should all be able to see that these two arcs can be put there because this is the vertical angles congruence theorem. So anytime we have vertical angles, that's the reason. Vertical angles congruence theorem. Now I want to talk about what do we see in this triangle. Hopefully you guys can see that triangle ACB was congruent with triangle ECD. That was because they were vertical angles. Then we can say that triangle ABC is congruent with triangle EDC. EDC by what? Hopefully you see side, angle, side. All right, this one on the bottom, we have two triangles. These triangles are isosceles triangles. because the one on the left has base angles that are congruent. The one on the right has sides that are congruent. Well, if the base angles are congruent, first of all, we could find those base angles because we would subtract 100 from 180. That would give us 80, and then we would divide that by 2. So both of these angles would be 40 and 40. And we also know that these sides are congruent, right? So over here on the right, we have the same thing. Only now, because the sides are congruent, we know the angles are congruent. So here again, these angles will be 40 and 40, and our sides will be congruent. So hopefully you can see here that PQ and QR and ST and TU would all be congruent if both of these had 2 ticks. Sorry, I should have put 2 ticks over there, right? Okay, and then we have our base angles that are congruent. So these triangles are congruent. Really, you could use a lot of different ways. You could use side angle side. You could use angle angle side. Well, I shouldn't say a lot, those two, because we obviously can't use side 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 because we don't have the third side, okay? So here again, what do we know? We know that angle S and U, angle S, is congruent with angle U, is congruent with angle P, is congruent with angle, R. We also know that PQ is congruent with QR, PQ congruent with QR, congruent with ST, congruent with TU. All right, and then, like I said, we could say that the two triangles are congruent. So here we could say that triangle PQR is congruent with triangle STU. And we could do all of this because of the isosceles triangle theorem. And what was I going to say? Again, these triangles could be congruent by side angle side or angle angle side or angle side angle. So you could have said side angle side or angle angle side or angle side angle. Any one of those would have worked for this one. So our last two concepts, I don't know where in the world my triangle went. Oh, there it is. We have that AD bisects angle A. Well, again, we have a shared side here. So we're going to put 2 ticks on that. And if AD bisects angle A, then we have that those two angles are congruent. So here again, we can say that angle BAD is congruent with angle CAD because of the definition of an angle bisector. Okay, then we can say that triangle BAD is congruent with triangle CAD. And the reason they were congruent was side angle side. Okay, our last one. What can be concluded about angle C and angle F? Well, everybody should see that angle B and E are congruent and angle A and D are congruent. So that means that C has to be congruent with F because of the third angles theorem. So this is the third angles theorem. However, we cannot prove congruence here because what we have right now is angle, angle, angle. So we don't have enough information because we do not have a side. So we cannot prove congruence here. Now they might be congruent, but we can't prove it.